Another important topic in Unit 4 is problems of harmonics. The problems of harmonics mainly the telephone interference. What is telephone interference? So the telephone interference is nothing but radio interference which gives more noise in telecommunication lines, more disturbances in telephones. Normally, the main cause of telephone interference because of corona. So what is corona? The corona is a ionization of air surrounding the power conductor. That means the intensified ionized particle concentrate near the surface of the conductor causes corona occurs. The main features of corona, main characteristics of coronas are first one hissing noise, violet glow, producing ozone gas. This hissing noise causes normally power conductor lines and telecommunication lines both are nearly erected. The telecommunication lines absorb this noise which causes due to the corona that is delivered to the telephones which cause more disturbances. So the telephone interference can be avoided by using the conductor must be a transposition. Changing the position of conductor causes some of the telephone interference or radio interference will be reduces. In transmission line, the main consideration to erect the transmission line main consideration is a based on corona loss. Telephone interference. Second one is power losses. So whenever the power losses of harmonics, so the overheat produces in a system due to the harmonics. Whenever the overheat is nothing but power loss in a system. Heating in a machine and capacitors due to overestimate of waveform due to over because of harmonics that gives overestimate of the waveform causes heating in machines and capacitors. Normally capacitors are the reactive power compensators. So the capacitors, the heating occurring in capacitors. Over voltage due to resonance conditions. Also a problem of harmonics. Instability of converter controls. What is the stability? The stability is nothing but the steam input power must be equal to the electrical output power. So normally this is in AC system. So instability problem occurred in mainly in AC system whenever the frequency not matching in two generating stations or more than two generating station causes there is the instability problem. The harmonics also one of the cause for instability. Another one is interference with ripple control system. Already I told that what is the interference. So what are the causes for interference? Extra filter cost. Whenever the harmonic content increases, the filter cost also increases. In order to decrease the filter size, whenever the filter size decreases, cost also decreases. How to decrease the filter size means increasing the pulse number in converter circuits. By increasing the pulse number, we can easily decrease the filter size that causes decreases the causes of cost of filter. Suitable filters were needed to suppress carrier and radio frequency harmonics. So there is a number of elements are there due to the harmonics. So that harmonics can be calculated by using the formulas. The first one is harmonic distortion. How much distortion will be there in due to the harmonics can be easily calculated by using harmonic distortion factor, that is the HDT, harmonic distortion HDF. Harmonic distortion is given by D is equal to N is equal to M IN Zn by E1 into 100, where IN is the harmonic current injected, Zn is the harmonic impedance of the system, E1 is the fundamental component of line to neutral voltage, M is the highest harmonic considered. Harmonic distortion is also given by harmonic distortion. Another formula is DRSS is equal to sigma n is equal to M IN Zn square whole power 1 by 2 by E1 into 100. So this is a harmonic distortion factor. So the main aim to find the harmonic distortion factor is how much harmonic content, how much harmonic noise is there in a waveform. We can easily analyze by using harmonic distortion. So this is a very important and mandatory to find the harmonic distortion by using these elements. So the number of integer will be changed to M. So the formula is INZN by E1 into 100. The second factor is telephone influence factor. How much disturbances occurred in communication lines is also one of the important factor. How much noise, how much disturbances is produced it is must and should you can find out by using telephone influence factor, that is a TIF, an index of possible telephone interference, and is given by telephone influence factor is equal to N is equal to M IN Zn Fn whole square whole power 1 by 2 by E1. This is a telephone influence factor. The main aim of to find out the influence factor, how much disturbances occurred in communication lines. That's also finding very important. So we must find out the telephone influence factor in harmonics, where Fn is a 5n Fn Pn. Pn is the C message waiting used by Bell Telephone System BTS and Edison Electric Institute EEI in USA. So in any transmission system we can find out the telephone influence factor by using this formula. This weighting reflects the frequency dependent sensitivity of the human ear and has a maximum value at the frequency 1000 hertz. The frequency is 1000 hertz. How much the disturbance occurred in human ear? We want to find out by using telephone influence factor. The telephone influence factor formula is this one. Telephone harmonic form factor. Already we know the form factor is nothing but RMS value by average value in AC quantities. We know that one. So another definition for telephone harmonic form factor is a telephone. It is similar to the telephone influence factor and is given by Fn is equal to NFN by 800 into omega n, where omega n is a weight at the harmonic order n defined by the Consultative Commission on Telephone and Telegraph System CCITT. CCITT means Consultative Commission on Telephone and Telegraph System. TAF is used in USA. THFF is popular in Europe. Different countries finding different factors. So some countries find out TAF, some countries finding the THFF. IT product. In BTS EI system, there is another index called IT product and is defined by IT is equal to N is equal to 2M IN Fn whole square whole power 1 by 2. So these all the factors are very important. How much the harmonic content is there in a waveform, how much disturbances are raised is a finding is very important. Before going to the system analysis, we must find out these all the factors one by one. So, elimination of harmonics and suppression method. So, there is a number of harmonics are present. We know that one in any HVDC system. We have both AC system and DC system. Definitely, there is a more harmonics are present. So, wherever the more harmonics are present, there are number of disadvantages. Already we seen that there is a lot of power loss. There is a more interference problems, so there is over steam causes, machine heating. These all are the main drawbacks of harmonics. So how to eliminate harmonics is a very important phenomenon. The harmonics are eliminated by using two methods. The first one is by increasing pulse number by using filter circuit. By increasing pulse number means, so if you increase the number of pulses, what is the pulse number? Normally the pulse number is 6, 12, 24, 48, and so on. By increasing the number of pulses, we can decrease the harmonic content. Whenever the harmonic content decreases, the filter cost and size also reduces. But increasing the pulse number is nothing but increasing the converter cost. The converter having more valves, the valves is nothing but GTOs or IGBTs is very costly. The one method for elimination of harmonic is by increasing pulse number. If you increase the pulse number, automatically the harmonic content reduces, the filter cost and size is reduces. The second method is by using filter circuit. So the filter is nothing but that will eliminate harmonics. So basically there are two types of filters, AC filters and DC filters. Depend upon the frequency content in waveform, we can use the filter circuit. Which filter is better for which frequency is a very important phenomenon. Thank you.